Hi students, welcome back to my channel Evolve Solving Physics. Today we are going to discuss about scalars and vectors. In motion in a plane, we discussed that to describe any physical quantity we use vectors. To describe any physical quantities, we use only the vectors. Before going to discuss about vectors, we are going to discuss about scalars also. What is meant by scalars and vectors? Before knowing about scalars and vectors, we are going to discuss about what is meant by physical quantity. Physical quantity means measurable quantities are called physical quantities. So measurable quantities are called as physical quantities. All measurable quantities are called physical quantities. So mostly physical quantities are divided into two types, that are scalars and vectors. So most of the physical quantities are classified into scalars and vectors. So what are measurable quantities means, as you all know that we can measure speed by speedometer. So that is an physical quantity. We can measure the distance, displacement, velocity, acceleration. So all that are physical quantities. So that are measurable quantities. So all measurable quantities are called physical quantities. So most of that physical quantities are divided into two types, that are scalars and vectors. So what is meant by scalars? So what is meant by scalar? Physical quantities having only magnitude are called scalars. So only magnitude means, what is meaning of magnitude? Meaning of magnitude represents size or length. So any object length represents magnitude, and in some cases the size can also be represented as a magnitude. So the meaning of magnitude can be taken as length. Maximum we take it as length. In some situations or some cases we take it as size as a magnitude. So magnitude meaning represents length. So the quantities which have only magnitude, that are called scalars. So for example, length, time, volume, density, temperature, mass, work, electric charge, electric current, etc. So these are some examples for scalars. So these are all depends on the magnitude, containing only magnitude. So that called as scalars, that we call it as scalars. All these physical quantities are called as scalar. So size or length represents scalar. So how can we describe an scalar or scalar quantity? So length can be considered as scalar quantity. Time can be considered as scalar quantity or scalar. So this is an quantity which is an scalar, so we representing it as a scalar quantity. So what we need to describe an scalar quantity? We require unit for an quantity, the specific unit of that quantity. So to describe scalar quantity, first we require unit of that quantity, and next the number of times that unit is contained in the quantity. So for suppose a bag contain 500 kg of sugar. So 500 kg of sugar means the kg represents specific unit and 500 represents number of times the units is contained. So this is an scalar quantity. This represents mass. 500 kg represents mass. It is an scalar quantity. So kg is the unit that we should specify, and 500 represents the number of times that the unit has been contained in that quantity. So scalar quantity means the physical quantity having only magnitude that should contain units and number of times that units has been contained. In some situation, in some cases, the substance which do not, or the quantities which do not have units can also be considered as scalars. For example, refractive index. Refractive index, it does not have any units, but we consider it as scalar. So for some physical quantities, only for some physical quantities which they don't have any units, that can also be considered it as a scalar. So maximum quantities require units and number of times that unit has been contained in that quantity. So one of the physical quantity which do not have units, that can be considered it as scalar as refractive index, specific gravity. Specific gravity. So now what is meant by vector? So physical quantities having both magnitude and direction, that we call it as vectors. Having both magnitude and direction, and that should obey law of vector addition. Are called vectors. So we discussed that scalar means physical quantities having only magnitude, that we considered it as a scalar. So the physical quantities should have both magnitude and direction. Magnitude means length as well as direction, and should also obey law of vector addition, that we call it as vectors or vector. So it should also follow the law of vector addition. What is meant by law of vector addition means that we are going to discuss in next classes. So just remember that if it has only magnitude, the physical quantity having only magnitude, that we consider it as scalar. If a physical quantity having both magnitude and direction, and it should obey the law of vector addition, that we call it as. First, suppose if a physical quantity is having both magnitude and direction, but it does not obey the law of vector addition, means we consider it as a scalar. So first, suppose electric current. Electric current is a scalar. Electric current, as you all know that the electric current having magnitude, also direction, but it does not obey the law of vector addition, so we consider it as scalar. So if it has magnitude and direction but it does not obey the law of vector addition, means that physical quantity can be considered it as scalar quantity. So if the quantity which follows these three conditions, that we consider it as vector. So examples for vectors examples: displacement. So displacement means, as you all know, that displacement means distance with direction. distance is considered it as scalar as it represents length, as well as direction represents the distance with direction represents displacement, and it follows law of vector addition. So we consider it as a vector quantity. So displacement, velocity, acceleration, force, momentum, angular momentum, moment, torque, moment of force, magnetic moment, etc. These are the physical quantities are examples for vectors. So these are the quantities and some of the quantities which obey law of vector addition and they have magnitude and direction. So how can we describe these vectors? It described as same as scalars. So vectors can be described as, in scalar what we said, the quantity should have units and number of times the units has been contained. That are the 2 points we have mentioned to describe the scalar. Same as vector, units of specific physical quantity, number of times the unit is contained in the physical quantity. So these are the 2 points which is similar to the scalar, which is same for vector also. But one of the important thing to identify which is a vector quantity and which is a scalar quantity. So a plane is flying from west to east with a velocity of 50 meter per second. So here meter per second is the units of the quantity, that is velocity, and 50 represents number of times that the unit has been units contained in the velocity. So 50 represents number of times the unit is contained in the velocity, that is 50. So east to west means here we are representing direction. So one of the main point which we can identify the physical quantity scalar or vector, that is direction. So here we are representing direction. So these can be said as vector, velocity can be said as vector. So east to west is the direction represented by the physical quantity, that is velocity, and these two are the units and number of times the units has been contained in the velocity. So these are the points which is used to describe physical quantity, which is similar as scalar. One thing that I have mentioned in vector quantity is direction. So that is the difference between scalar and vector, that is direction. So scalar means having only magnitude, vector means having magnitude and direction, also should obey law of vector addition. So that is a vector. So if you have any doubts, please comment me in comment box. So we will discuss next topic in next video. Please like, share and subscribe my channel. Thank you.